Hi, and welcome to our lesson on moles. And not the mole that digs up your yard that affects your volume and your concentration, but we'll be talking about mole in terms of chemistry and the mole concept. So, a mole is the amount of material that is that contains 6.02214 times 10 to the 23 particles. And if you've never heard of this number before, this number is also what we call Avogadro's number. So 1 mole of sand will have 6.022 times 10 to the 23 grains of sand. A mole of carbon atom will have 6.022 times 10 to the 23 atoms, and a mole of water molecule will have 6.022 times 10 to the 23 water molecules. So it's the amount of material containing 6.022 times 10 to the 23 particles. So again, that's the number of particles that you will have in pretty much anything when you describe a mole. So a mole is also equals to 12 grams of pure carbon 12 isotope. So 12 grams of pure carbon 12 is equal to 1 mole of carbon atom, which is also equal to 6.022 times 10 to the 23 carbon atoms. We often use the number of moles to help us with our calculations. For example, you're often asked to calculate the number of atoms that are found in a particular number of moles. So, in this example, you were asked to calculate the number of copper atoms in 2.45 moles of copper. Well, we know that 1 mole of copper will have 6.022 times 10 to the 23 atoms. Therefore, 2.45 moles will contain 2.45 multiplied by 6.022 times 10 to the 23, which is equal to 1.48 times 10 to the 24 copper atoms. In this example, you are asked to calculate the number of moles found in a particular mass of a carbon found in lead pencil. So here we know that 1 mole of carbon will weigh 12 grams. Therefore, if you only have 0.0265 grams of carbon, then you will have 0.0265 divided by 12 to give you the number of moles in that given mass of carbon. Oftentimes, you are asked to calculate the number of atoms. And since 1 mole of an atom contains 6.022 times 10 to the 23, then the number of moles multiplied by Avogadro's number is equal to the number of atoms. So, early on, we calculated the number of moles to be 2.2 times 10 to the 3 moles. Multiply that by Avogadro's number, which is 6.022 times 10 to the 23, and you will find that you have 1.33 times 10 to the 27 atoms in that 0.0265 gram of pencil lead. Now, you would notice in your periodic table that the elements are surrounded by the atomic number as well as the atomic mass. The mass of 1 mole of any element is called its molar mass, and the element's molar mass in grams per mole is equivalent to the element's atomic mass in AMU. So in the periodic table, you're seeing the atomic mass in AMU, or atomic mass units, and that is equivalent to the molar mass in grams per mole of that element. Therefore, 4.003 grams of helium is equal to 1 mole of helium, which is equal to 6.022 times 10 to the 23 helium atoms. Similarly, 26.98 grams of aluminum equals 1 mole of aluminum, which again is equal to 6.022 times 10 to the 23 aluminum atoms. Now, molecular mass is also called the molecular weight is the mass of an individual molecule or of its formula unit. And the molecular mass of a compound is the sum of the masses of the atoms in a single molecule or formula unit. Therefore, it is equal to the sum of all the parts. So the formula mass is equal to the number of atoms found in the element multiplied by the atomic mass of that element. And then you add the number of atoms in a second element multiplied by the atomic mass of that element. And the total will give you the molecular or the mass of a compound. So, of course, these relative masses of molecules are derived from the atomic masses. So, 1 mole of H2O contains 2 moles of hydrogen and 1 mole of oxygen. So, molar mass is equal to 1 mole of H2O, which is equal to 2 times 1.01 grams, which is the mass of hydrogen, plus the 16 grams, which is the mass of oxygen, to give you the molar mass of the compound of 18.02. And so this is how you can use moles in a lot of the calculations that you will come across in general chemistry.